Hello, and welcome back to another episode of the Legrand Data Center Insights podcast. I'm your host, Emma, and today we're diving into a topic that's rapidly transforming the data center industry: the impact of artificial intelligence on data centers. We'll explore how AI is changing the game, the challenges it brings, and some innovative solutions that can help data centers navigate this new landscape. So, if you're keen to stay ahead of the curve, stick around. Artificial intelligence is no longer a futuristic concept. It's here, and it's reshaping the way data centers are designed and operated. One of the most pressing concerns with the growth of AI applications is the significant increase in power consumption and the need for high-power density environments. These changes are forcing data centers to rethink their physical infrastructure requirements entirely. To give you a bit of context, let's look back at where we started. In the late 1970s, data center power density was generally between 2 to 4 kilowatt. Fast forward to today, and it's not uncommon to see densities exceeding 40 kilowatt to accommodate AI or high-performance computing workloads. Just to put this into perspective, Silicon Valley Power has projected that by 2035, the annual data center load could almost double its current system load. That's massive growth! For decades, data center infrastructure design has remained fairly consistent. Traditional designs focused on ensuring the basics: power, network, cooling, and security, typically running between 5 to 7 kilowatt, with 15 kilowatt considered high. But AI has disrupted these traditional power requirements, increasing rack density and power demands dramatically. As Colm Shorten, Senior Director of Data Centers at JLL Real Estate, puts it, AI has challenged what those power requirements are. More power means more heat, and more heat means you need to figure out new ways to cool those racks. David Bradley, Regional Director at Legrand Data Center Solutions, echoes this sentiment, stating, "There needs to be a mind shift now on how we cool these racks and deliver the power based on AI demands." With computing power and chip designs advancing at such a rapid pace, equipment racks are doubling in power density every 6 to 7 years. This shift is pushing the industry towards more innovative cooling methods, such as liquid cooling, which comes with its own set of challenges, like installation complications and sustainability concerns. But it's not just about cooling. AI workloads add another layer of complexity to data center operations. In the past, data centers were often located near cloud regions or densely populated metro areas to bring power to them. But now, with AI training not being as latency dependent, there's a shift. As Shorten says, now you bring the data center to the power. This flexibility opens up new possibilities for data center placement and design, particularly in more remote or energy-abundant areas. Of course, with these shifts come new network and redundancy requirements. As AI demands surge, network needs intensify, placing added stress on data centers to maintain robust connectivity and low latency. High reliability mechanisms, like seamless switching between power sources, become critical to prevent downtime. And don't forget the risks associated with power surges and harmonic distortions caused by non-linear components. These can lead to overheating and safety hazards if not properly managed. Looking ahead, there's a growing emphasis on future-proofing data center facilities. Shorten emphasizes the need for hybrid solutions to avoid obsolescence. If we build a pure traditional model, there's a risk of it becoming obsolete in just a few years. The demands on physical infrastructure are significant, from weight loads to cooling requirements, and they can exceed the limits of older data centers. Bradley points out that you could add 200 to 300 kilograms of weight on a rack, and not all floors can handle that. Now, let's talk about some of the biggest challenges facing data centers today, beyond just the physical issues like space and cooling. Data center operators are also navigating an increasingly complex regulatory and sustainability landscape. Regulatory frameworks are struggling to keep up with the rapid pace of technological advancements, making it harder for operators to stay compliant. And then there's sustainability. AI is driving up energy consumption, making it even more difficult to meet sustainability targets. In fact, according to the Uptime Institute's 2022 Data Center Industry Survey, 63% of operators expect mandatory sustainability reporting within the next 5 years. This is where regulations like the Corporate Sustainability Reporting Directive, or CSRD, come into play. Starting January 1st, 2024, this will impact many EU-based businesses, requiring them to report on their sustainability efforts. On top of that, the Assessment Framework for Data Centers, part of the EU's Taxonomy Climate Delegated Act, requires a third-party audit every 3 years. And, starting September 15th, 2024, the European Energy Efficiency Directive will mandate annual reporting on several key metrics. In short, data center operators are facing a double challenge, managing the technical demands of growing technology while staying on top of evolving regulations and sustainability goals. And let's not forget the security risks. AI brings new challenges, including automated attacks and vulnerabilities that can be exploited by bad actors. As Shorten rightly says, AI is a double-edged sword. It's fantastic for spotting changes in patterns, but it can also be wielded by those with malicious intent. Therefore, advanced encryption, biometric authentication, and robust cybersecurity measures are essential to counter these new threats. So, what's the way forward? How do we manage these challenges? At Legrand, we're focusing on innovative solutions that help address these complex issues. To manage thermal challenges, designs like U-System's rear-door coolers efficiently remove heat at the source, supporting high-density environments without massive infrastructure changes. Similarly, liquid cooling solutions, such as direct-to-chip or immersion cooling, are proving to be more effective for AI-driven workloads compared to traditional air cooling. For power management, intelligent rack PDUs like the Raritan PX4 are designed to handle high power densities and ensure optimal energy usage. And to maintain flexibility and future scalability, our modular track busway solutions provide efficient power distribution while offering the adaptability that modern data centers need. By adopting advanced cooling, intelligent power distribution, and scalable infrastructure solutions, data centers can meet the demands of AI without compromising on efficiency or sustainability. The goal is to stay ahead of the technological curve while managing costs and environmental impact. Thank you for joining me on this episode of Data Center Insights, sponsored by Legrand. I hope you found these insights helpful as we navigate the future of AI in data centers together. Be sure to subscribe and share this podcast with your colleagues. I'm Emma, and I'll be back soon with more on the technology shaping our digital future. Until next time, stay ahead of the curve and keep your data centers running efficiently.